Alright, so today we're going to look at setting up tool frames. Now the tool frame is used to as part of every point in every single program. So what you have to do is when you have a tool, you have to give it a tool frame. Now with this particular tool, we actually have two pointers here. And so we actually need two tool frames, one for each tip of the pointer. Now right now I've actually got it set, so you can see I use this cone as just a teaching device. And so what we need to do is we need to teach that tool center point. So the idea of the cone is to just hold that tool center point to just give us a point in space as a reference point. All right? So while we're trying to teach a tool frame, we got to remember a couple of things. Number one, we don't want to move the cone because we'll lose that point in space. If we move the cone over here, now it's a different point in space. So we're trying to keep the tip of this cone as our reference point, but we need to keep it in the same thing until the tool frame has been taught. The other thing is you should not be in the frame that you're going to teach. All right, so when we look at the teach pendant here, if we press menu will get us to the main menu screen, and then we want 6. So we come down to 6 for setup. Remember, you could just press the 6 button, or you can arrow down and press that. And then, depending on where you're at, you press type. Once you get to the setup, and you press type, and then you can choose frames. Now you notice it actually came up with frames because I had already been in here before. So the next time you press menu, it'll actually just pull up the last screen that you were on. All right, so then you can see there's 10 different frames here. And we're going to want to teach one of these. So I'm going to teach number 4. You see number 4 is cleared out. It's all zeros. And so I'm going to teach frame 4. So I'm going to press enter here and go into frame 4. Now when I go into this, I'm going to, I can put in a comment. So here's a comment field. If I press enter in the comment field, then I can come in here and I can, label this the left. I can come in here and select the left tip or whatever, and you can give it a name. Okay, I'll just call it left for now. So you can label that. And then you have your XYZ, yaw, pitch, and roll. That's going to be where that tool center point is in space. All right, and every program that you run is going to be based on whatever tool frame that you're using for that. And what that is, let's say we're going to do this, the left tool tip here, and and left looking at it, which is actually the right one for the robot, I guess. But we're going to teach this tool tip right here. So right here at the tip of this pointer is going to be the tool tip I want to do. So when I do that, what I'm going to have to do now is I'm going to have to move the robot. Well, I could do it several different ways. If you see F2 here is method, if I press that, these are the different choices that I have for teaching the tool frame. And so what I'm just going to cover here is the 3-point method. But one entry, what I've got actually right now is the 6th choice, which is direct entry. So if I know what these values are, I can just punch these values in. So I could say, okay, well, I know this is 33, and I can just punch these values in. All right, and so most tools are designed on a CAD system. So if you have the CAD drawing, you actually are going to know those numbers and you can punch them in. However, sometimes the tool may get bent or something, and you still need to use it until you get a replacement. So you may have to reteach the tool frame using a more manual method to teach it because of the bending of the tool tip or something like that. So I'm going to do the 3-point method here. And the 3-point method, you have to approach the point in space that you're going to go to and by 3 different directions. So remember the Cartesian axis. So if you have your Cartesian axis, you have an X. Really with the right hand, we have an X, a Y, and a Z. Okay? Using the right hand rule, we have X, Y, and Z, this Cartesian axis. And so what we need to do, what we're going to be doing is we're going to be shifting that. So we have to come down at it like a standard Artesian. All right, so here, you have your standard Artesian coordinate system. So you have an X direction, a Y direction, and a Z direction, and these are all perpendicular to each other, right? There's a 90-degree angle from all of these. And so what you have to do, we're trying to get to a point in space, which is going to be our tool center point, or basically our origin, and we have to come in at it from 3 different angles. So we're going to use the 3-point method, so we're approaching from 3 different angles, and that will define this point in space. So to do that, one of the things that we can do is we can make use of data registers or position registers. So if we press the data button, we get the position. You get the data screen. Now, it usually defaults to the data register screen, but if we press F1, we can come down here to position registers. Position registers remember a point in space, but they remember that point in space based on your current frame. So remember, I'm going to teach frame 4, but I don't want to be in frame 4 while I'm teaching it. Okay, so I don't want to use tool frame 4. So if I press shift chord here will give me, tells me that currently I'm in tool frame 1. All right, so I'm in user frame 0, tool frame 1, and my jog frame is 1 also. So I press shift coordinate to get that. All right, so I'm going to press, if I wanted to change this, like if I wanted to change it to 4, I could simply press 4 and hit enter, and that screen disappears, and you can't really tell what frame you're in, but press shift chord again and you see that now I'm in frame 4. So I want to go back to frame 1 for right now. So I've got tool frame 1, I press that. So now I can record points in space using a position register, and then you see the F2, if I do a move to at F2 here, I can actually move to those points. So right now, I'm sitting here at this point in space, and so now, if I wanted to jog around this, now remember I'm in tool frame 1, so I've actually already taught tool frame 1 to be right here at about where the tip of the cone is right now. So if I jog this robot, you see that tool frame, the tool center point, it's moving right around the center of that cone. So that center point at the tip of that cone is not really moving. Okay? And so that is my tool frame. All right. Now, when you're in the tool frame, minus Z is up, and you know, like if the tool is pointing down like this, like these pointers are pointing down, minus Z is in the opposite direction. So if I do a minus Z, I'm going to go up. Now notice this, if I rotate this a little bit, and now if I do a minus Z, now minus Z is going this way. It's going in the opposite way that those pointers are actually pointing. So minus Z is the opposite direction that they're pointing, because my tool frame is right here, and so plus Z is straight down, so whatever direction that is pointing. So I'm going to go ahead, I've already taught this one tool frame. So when you're using the position register, if you do a shift record, shift F3 will record that. You can see the R tells you that it's been recorded. So I've recorded it, so I'm going to do a move to, and we're going to see where this ends up at. Okay? And so you can see that it actually is ending up right pretty much back where it started from. All right. However, if I move to a different tool frame, if I change, so I'm going to do shift chord again, and I'm going to go to tool frame 2. Okay. So I'm going to go to tool frame 2, which has actually already been taught to be the tip of this pointer. Okay, so I've already kind of taught tool frame 2. And so if I minus Z to get it back up. So one thing you got to be careful when you're doing the move to, you always want to get away from any obstacles so you don't accidentally run into them before you do a move to. So now I changed my tool frame from 1 to 2, and my tool frame is 2 is different. So let me just show you the tool frame. Menu, 6, hit previous to get back, so you can see that tool frame 1 is 0020, but tool frame 2 is 05170. So since I changed my tool frame, now if I go back to my position register and do a move to, you can see that move. All right, and so now it went to that tip. Now if you look, if we go back to our tool frame again, so go back to frame, and you see that frame 3 is minus 51. Okay, and so I'm going to minus Z to get away, just so it doesn't bump it when you do the move to. I'm going to go back to data, and this time when I do a move to, oops, I got to do a shift chord. I got to change it to tool 3. Forgot to change it to tool 3, and now I'm going to do a move to, and now notice it's going to move to this point because it's a different tool center point. But position registers, and you need to remember this about position registers are a point in space, but that point in space is based on your tool frame. So if we press the F4 here, position button, you see there's a UF and a UT. Those are your user frame and your user tool. And the F just means your current frame. And so you, whatever current frame you're at, that's that point in space. So these numbers you're looking at, like X292 here, so X292 is the distance from the origin of your robot, which is back here at the base of your robot. Remember, the origin is where the second axis and the first axis, this is your first axis, this is your second axis, the origin is at the center point of those. So this is saying we're coming out from the center of this. I can't even put my finger on it because it's in the middle of the robot. But we're coming out 292 in the X direction. Okay, that is straight out from the robot. Then we're going minus Y 327. And then we're going in the Z minus 41. So that origin, actually it wasn't right here. Sorry, this is the joint. It's the second one. So it's coming out, straight out from the robot. Where's my Cartesian axis here? So it's coming straight out from the robot in the X direction. So it's coming straight out, and then minus Y, so it's going in the minus Y direction, and then it's going in the minus Z. Okay. And so that's why we see those numbers there. That's that origin. But if this is tool frame 3, this is this point in space. Now notice it's the point in space is at the top of the cone. The point in space isn't changing. But if I change my coordinate system back to 2 for the tool frame, if I change my frame back to tool frame 2, and then I do a move to again, see, it's the same point in space, but it's the reference. Is it using this point, or is it using this point, or some other point? And that's why we have to teach it what tool frame we want it to use. And every point stored in the robot is tied to that tool frame and that user frame, unless we store the data based on the joint angles. So if we look at position, you see the position, the X, Y, Z, yaw, pitch, and roll. But if you choose F5, it's called representation. And if I choose the representation to be joint, then it's going to store the values as the joint rotations that get it to that place. Okay? So that doesn't depend on the frame. Those are just the joints no matter what. But if you store it on as a Cartesian, it tells you, it gives you a warning here when you do that it's being stored. This point is stored, and it's this point in space, but only for this user frame and this tool frame, as it's showing you on the display there. All right, so now if we want to teach this tool frame, we're going to go back to frames. So I'm going to come back to frames, go to setup. I'm going to go to tool frame 4. I'm going to choose the method. The method I'm going to choose is the 3-point method. And then I'm going to choose approach point 1. So this is approach point 1. Now remember, I've got to come in from 3 different angles. Now it doesn't matter as you rotate this, right? This is a Cartesian axis, and you can rotate this Cartesian axis any way you want, but our goal is to get this center point, the origin of this. So it doesn't matter how this is rotated, but when we come to it, we want to be perpendicular from 3 different approaches, and that's what this is saying. Now, you don't have to be perfectly perpendicular, but it really helps if you are. So if you look at the robots, we actually use we actually got some squares here that we can use to kind of help us to make sure that, you know, the pointer is as straight as possible and all that kind of stuff. So now when you're doing your first point, okay, you can pick that first point anywhere you want. So you just kind of put the cone out there and say, this is my point in space, and then you move the robot to that point in space. You want to make sure that it's as perpendicular as possible, and then and not only just from one angle, but look at it from the other angle also. So you want to, you know, kind of look from all angles. So you need to actually move around here a little bit, get in here, make sure that it's as perpendicular as possible for that first point. So once you've got that first point, you can't move the cone. Okay, but when you're first starting that very first point, you know, if you're like, you know what, I want to move it for a little bit, it's okay to move it. But once you get your first point and you're trying to teach a second and third, you can't move that cone. Now again, the cone is just a reference. What we're really doing is teaching this point in space right here. All right. But the cone is just like a visual reference for us so that we can see that. So this is my first point. I'm teaching this tool center point to be the tip of this pointer right here. And so I'm going to mark that point with the cone. I'm going to come over here. Now, we've already used this user frame, so you can see it says approach point 1 has been used. But I'm just going to re-record over top of that. So I'm going to press record. Okay. So approach point 1. Okay, I'm going to clear this frame. Alright, so I just cleared the frame. I ended up clearing my comment out also. Alright, so we're just going to recreate this. And so now I've recorded this one point. Okay. Notice that all the values, I think why it wasn't working was I forced these values to be 0, but I didn't clear the frame so that those points were initialized. But the frame is all zeros right now. Once I record the next 2 points, as soon as I record that third point, you'll see numbers appear for all your yaw, pitches, and rolls, X, Y's, and Z's in there. And you'll see it fill out as soon as I press that third one. All right, but so this is my first point. Now what I need to do is I need to rotate 90 degrees and come at it from, so this is, if you think about, we're coming straight down here, so this is point 1, and I need to come in at it at another direction. The easy way to do this is with this position register. So I'm going to go to data, and again it returns to position register. I'm going to go to position register 2, which is the point where I'm at. And what I'm going to do is I'm going to record this point. I don't know what's in here. It's been recorded before, but I don't really know what's here. So I'm going to record. This is point 1. I'm going to go ahead and record this point. Okay, so I've recorded this point. Now what I'm going to do is I'm going to rotate this point 90 degrees. So I'm going to hit position. So I'm going to press F4 to go to position, and I'm going to go to my roll. And at the roll, you can see the roll is currently 1.856 degrees. So I want to rotate it 90 degrees, so I'm going to make it 91.856. So I'm going to just put in here 91.856, enter. All right, so this is where I want to go. Okay, this isn't where I'm at now. I recorded this point, and I was there, but the roll was only 1.8 degrees. Now I'm going to make it 91.8. So I'm going to press done, and I'm going to do a move to. Now when you do the move to, make sure you slow it down here. Don't let it move too fast in case it moves your cone. Or as I said before, you should also probably move away from the cone, because we can't move that cone until we got all 3 points taught. So now I'm just going to do a move to. And I'm going to do a move to, and I'm going to move to this point. Remember, I'm teaching frame 4, but I'm currently in frame 2. So now you see that rotated 90 degrees. Again, let me just kind of flip back through here. I'm going to move back to point 1. Right? This was point 1. And this is point 2. It's just rotating 90 degrees. And so it's the same point in space, but the robot, something on the robot has rotated 90 degrees to get there. So now I'm going to press menu 6 to get back to my frame. I'm going to come down to point 2. Boy, don't forget, I've done that so many times, and I left it on approach point 1, and then I hit record again, and so I lost my first one and recorded the second one as point 1. Come down to point 2, do a shift record. That records point 2. Again, the XYZ is still all zeros, but as soon as I get my third point, it won't be. Now, to get, when you look at your XYZ here, the X and the Y are kind of in the same. So all I did was like rotate the X and the Y. But now I got to do the Z, which is coming in from a completely different angle. So we kind of have to flip the robot down on its side. So I'm just going to come over here and I'm just going to, and we can kind of watch this. If we go and look at it, you see the yaw, pitch, and roll. Yaw is 179, 180. Roll is 91 because I just rolled it. But now I need to change that pitch. Okay? So I'm going to change a pitch. I probably could go back to the position register or do it, but I'm just going to show you we can just kind of take J5, and I'm just going to lay that right down perpendicular. So now it needs to be horizontal So you can see there I'm like 88, 90. So it's, now I bumped it, but so you see I just laid it down. Now we want it really should be as horizontal as possible with the floor or your platform. Okay? And that's point 3. So now we're going to hit menu, 6, go back to point 3, make sure we're on point 3 here, and do our shift, record. And now you notice they all say used, and then you can see these numbers. You see that Y is 51 and Z is 70. Okay? So it immediately set those numbers. Notice the yaw, pitch, and the roll, and actually all are 0 because this tool is perfectly perpendicular to the faceplate of the robot. All right? And so the only thing that we have here on the robot, is, this is our faceplate. So it comes away from the faceplate. That's your Z. So your plus Z is away from the faceplate. So it's 70 degrees. It's 70 millimeters, sorry, not degrees, 70 millimeters from the faceplate to the tip. And it's 51 from the center of the faceplate. It's 51 from the center of the faceplate over in the Y direction. Okay, so it's over in the Y direction, 51 this way, 51 millimeters from the center of the faceplate to the center of this tip, and 70 from the faceplate away from the robot out to the tip. All right, now that's the way that this thing was bolted on. You can see there's 2 bolts holding this on. We could have put all 4. Usually there's 4 in here, but so if your robot's in production, you probably want to have all 4 bolts in there. But if we unbolted this, there's 4 bolt holes. We could actually rotate it 90 degrees. So some of the other robots, it may be 51 in the X direction. I'm not sure what direction it's going to come up. But that, again, I know those numbers because that came right from the drawing, the CAD drawing that we used to actually create these pointers. So we knew what those numbers were ahead of time. But here is how we taught those. So now, once you've created these points, we can do a move to right here on this screen to return to that point. All right, so we could, but again, you need to move the robot away from your cone so you don't mess up that point, or you don't mess up the cone because when it does that move to, and I moved the cone out of the way because I was demonstrating there, but so there's that point. And then again, we can, let's move away from it a little bit. And I'm going to move to point 2, which again is just Point 2 is just that 90-degree rotation. So I'll do a move 2, and that's point 2. And then I'm going to get away from it again, and I'm going to move to point 3, which lays it down on the side. Now, again, you gotta, now when it's moving like this, if you press hold, it'll stop the robot, right? So remember that hold button will stop the robot. So anytime you're doing a move to and you're like, ooh, I don't want it to move, press the hold button and it'll stop. And then you can readjust it or something. So remember, if minus Z and plus Z is moving in the direction that the pointers are pointing, because that's what it's taught. All right, so but I'm going to go ahead and do the move to here again. So remember, the move to had it laid down. And watch it. If you need to, press hold to stop it, or release the dead man to stop it. But you can see there's that third point. All right, so now if I'm going to go back in there one time. I'm going to go back. I like to kind of start at point 1, so I'm going to move it away one more time and move back to point 1. All right, so I just kind of want to demonstrate to you this tooltip. So what we did was we taught this point in space. So the cone was just a marker, but we just kind of taught that point in space. So now, if I go to user frame or tool frame 4, so I go to I press Shift Chord and I select that to be tool frame 4. And then notice here my coordinate, I'm going to jog it in the tool frame, which is tool frame 4 because it's the number I just set. So now I'm going to jog this. I'm not going to touch the XYZ. I'm just going to jog. I'm just going to do the yaw, pitch, and roll. So I'm just going to kind of jog, yaw, pitch, and roll. So notice the right pointer here is moving all over the place. Okay. Oops. Let me return. I'm going to do a move to get back to my point there. I didn't mean to change X, Y, or Z. I just want to change the yaw, pitch, and roll. So I'm just going to jog and yaw, pitch, and roll, and I bump Z there. Okay. So you see that the right pointer is moving all over the place, but that left one is sitting right there. And I can jog this around, I can spin it, I can roll, change my roll, change my pitch, change my yaw, and that left pointer is sitting right there at that cone. Okay, if I move in the X, Y, and Z, okay, that happens to be the X at the moment. Remember, it's, all right, so I'm now putting the cone, basically, I'm going to put it kind of close to this one, and as I change my yaw, pitch, and roll, right, you can see it, it's drastically moving there. Okay, that one's not changing it too much, but if I do the roll or the yaw, it really adjusts it. So now, but if I change to tool frame 3 I've previously taught to be this tip. So now I'm going to change it to tool frame 3. So I'm going to do Shift Chord, press the number 3. Hit previous to get rid of that screen. When you, if you don't want to make a change, you can just hit previous to get rid of it. So previous will back you out of a screen. All right, but now I'm in tool frame 3, and I'm going to jog my yaw, pitch, and roll. So notice now it's the right one that's not moving. Okay? So when I adjust these, the right one is staying right there at the tip of the cone. So the right is staying right at the tip of the cone, and the left one is moving because tool frame 3 has been taught to be the tip of the right pointer. And tool frame 4 we taught to be the tip of the left pointer. So it's critical that you teach your tool center points.